In this video, we're going to talk about finding domain and range of inverse functions. As we already mentioned, that the domain and range for the inverse function will switch. So the domain of f becomes the range of the inverse, and the range of f becomes the domain of inverse. So let's take a look at some of the functions that we're already familiar with. And we're gonna take a look at whether they're one-to-one and if they have inverse functions. And if they're not one-to-one, can we do anything so that they would become one-to-one? Okay, so one of the functions that we already talked about was our quadratic function, right? So this is our quadratic function, and we mentioned that it's not one-to-one function because it doesn't pass the horizontal line test, right? But if we restrict our domain, we said that we're only going to look at x's that are greater or equal to 0. So basically, we're only looking at x's that are to the right of 0, to the right of the y-axis. Now this function, and we kind of like eliminate that piece. Now this piece of the function is going to be a one-to-one function, and it will have an inverse. And we're going to actually look at how we graph the inverse later. But that inverse function is going to look something like this, and we're going to call it a square root function. Okay, so we just take a piece of the x squared function of a quadratic function that piece is one-to-one, and we can figure out the inverse of that piece. Now that is exactly why we always assume that the square root is a positive. Okay, this is positive root of x. If we looked at this branch right here and found its inverse, that would make a negative branch for the negative root of x. So yeah, if there is no sign in front of the root, it's just that positive branch. Okay, let's take a look at other functions and see if they're one-to-one, and if not, can we make them one-to-one by restricting the domain? And we're going to take a look at the constant function, identity function, quadratic, cubic, reciprocal, reciprocal squared, cube root, square root, absolute value function. So the first function that we were looking at was our constant function, y o f of x equals some number. Let's say 3. So this is our constant function. And this function passes the vertical line test, but it surely fails the horizontal line test because the horizontal line y equals 3, it will coincide with this function. There's nothing that we can do. We cannot restrict our domain for this function to turn it into a one-to-one function. So it is a lost cause as far as inverse functions go. Okay, the next one is the identity function, which is y equals x, which is a diagonal line, and this function is one-to-one and it passes both the horizontal line test and the vertical line test. Okay, the next function is the one that we already talked about, is x squared. And we already talked about how we have to restrict the domain, and we're gonna only look at x values 0 and greater, so only the right side. Okay, next function that we're looking at is x cubed. Well, x cubed is a one-to-one function. It passes the vertical line test and the horizontal line test, so x cubed will have a nice inverse. Now, what about 1 divided by x? So let's 1 divided by x. This is our 1 over x function. And it does pass the vertical line and the horizontal line test. So yay, it has an inverse and we already know what it is. Okay, what about reciprocal squared? Okay, so here's our 1 over x squared function, and as you can tell, it doesn't pass the horizontal line test. So in order to find the inverse, we would have to restrict the domain. Again, just take one piece of it, maybe the right piece, for x's greater than 0. So that would be the domain for the reciprocal squared function. What about cube root? So I'm gonna write cube root as exponent, a negative not negative, fractional exponent. It's 1 divided by 3. So here's my cube root function, and it is a one-to-one function, and let's graph it next to the x cube function. Because we mentioned that they're inverses of each other, right? So the red one is cube root function and the blue one is x cube function. And look how pretty. Do you see the pattern? Do you see the relationship between those two graphs? I hope you do. I hope you're yelling right now that they are symmetrical. And what kind of symmetry is that? They're symmetrical about what? Are they symmetrical about the x-axis? Are they symmetrical about the y-axis, the origin, another line? Think about it. And while you're thinking, I'm gonna write the axis of symmetry. There you go. They are symmetric about the identity function or the diagonal line. And that's also going to be a very important for us when we learn more about reciprocal function. Inverse functions. Okay, so the next on our list is the square root function. Let's see. I'm gonna delete this one. I'm gonna turn the cube root into a square root. Here we are. This is our square root function, the red one, and I'm gonna graph it next to the x squared function. This is cubed. I'm gonna turn it into a square. There you go. So again, if you look only at this branch of the squared function, x squared function, it's symmetrical to our square root function. So those functions are inverses of each other. And last but not least, let's talk about, take a look at absolute value function. And here's our absolute value function, as you can tell, it passes the vertical line test, but it does not pass the horizontal line test. And again, in order for it to have an inverse, we are going to restrict the domain from 0 into positive infinity. But when we do that, it just becomes this one line, which is basically y equals x function, our identity function. Look, y equals x. So if we restrict our domain from 0 and to the right, then the absolute value function becomes just this y equals x function. All right, so this is it for our toolkit functions. And I have a question for you. If the domain of f is 1 to infinity, and the range of f is from negative infinity to negative 2, what would be the domain and range of the inverse function? I want you to answer that question. And I'm going to see you in the next video.